All right, well, anyway, good morning, and let's go ahead and get started then. All right, so what we are going to be doing by this lesson, we are going to be, well, we're going to be doing the same thing we did yesterday or the lesson before. We are going to be identifying the vertex and use the vertex to graph quadratic equations. But there is also one extra thing that we are going to do, and that is to create a vertex form so that we can graph it. So in order to learn how to do the vertex form, this is a fairly complicated process. It is indeed a fairly complicated process, so that's why I'm not making this entirely mandatory. Well, for this year anyway, for the fall 2020 year. So the trinomial for the form, and this is in standard form, ax squared plus bx plus c, where b divided by 2 squared equals a times c. So that does seem pretty complicated, but it's actually a little bit easier once you start working with it. But first we're going to need to factor some of these trinomials. Now, I know that when it comes to factoring, it can be a real difference in people's skill level for this, because some people are pretty good. Some people, I don't have to tell them anything and they already know what to do. Other people, you know, it's like they never learned it or something. But you do use it a little bit in geometry, but I know it, well, at least in my class, I know I teach factoring trinomials in Algebra 1. But we're going to do a quick review anyway. Now, there are many methods out there. Okay, there's quadratic formula, there is X method, and the problem with those methods is that in general, and this is my experience, a lot of students don't really remember it, you know. Like I'll show them my method, which I call the Loif method. It's basically FOIL but backwards. And these other methods, like I said, I'll get students to say, that's not the way I was taught. And I will say, can you show me the way you were taught? And most of the time they can't, because the way they were taught, like X method, works, but it's very complicated. It requires a lot of steps and direct placement of many elements to make it work. And with any machine, the more complicated you make it, the more likely something is to go wrong and the more complicated it is to fix it. So I'm going to try to keep it simple, and this is the way I remember it, because I remember also being taught many ways. And when I was out of high school and going into college entrance exam, I remember this is the method that I remembered. And that was like years after the fact, after I had left high school. So I call it the Loif method. I used to call it the double bubble method, which looked catchy, which sounded pretty catchy. And you start out by making 2 parentheses. That's why it's called the double bubble, because bubble is like the parenthesis. And what we got to do is look at the last number. So with the last number, and that's what the L stands for, we're working backwards. We have to think of 2 numbers that multiply to 16. So I can make a short list: 1 times 16, 2 times 8. I can't times anything by 3 to get 16. I'm only looking for whole numbers or integers. So I can't fit 3 in there, so let's try 4. So I can times something by 4 to get 16, and that's 4 times 4. Now, to get the middle number, we're trying to get 8. So what we do is we take these exact same factors and add them together. So 1 plus 16 is 17, so that's not 8. 2 plus 8 is 10, so that's not what we're looking for. 4 plus 4 equals 8. So these 2 numbers multiply to 16, and they also add to 8. So that means the numbers that go in here are 4. Now, in some cases, the sign does make a difference. If you have a positive, that's the easiest one to do, because, well, positive times positive is still positive. But sometimes you can also get negatives as well. You can get two negatives. So like if I had -4 times -4, it would be positive 16, but it would not add up to positive 8. It would add up to -8. But I'm going to, again, just try to keep things simple. So that's going to be positive 4 and positive 4. So x and x. So there you go. We have factored our first one. Now, it seems pretty complicated again, but it's actually not that bad. So let's go ahead and try the next one. So I'm going to make a double bubble, and I need two numbers that multiply to positive 1. And this is easy because there's only one set of factors. You know, 1 times 1 is the only way to get 1. There's not really any other way. And again, we only count whole numbers or integers. Now, both of them are positive. So this means that this second positive means that they are going to be the same sign. When they're both the same sign, that means that these two are going to be the same sign. Now, that doesn't mean they're both going to be positive. That means that they're both going to be the same. So they're either both negative or they are both positive. But in this case, they are whatever the first one is. So if this is positive, that means they are both positive. And this always works great when you don't have an A value. Now, since these two things are exactly the same, A plus 1 times A plus 1, this is what's called a perfect square trinomial, which is right here. So a perfect square trinomial, if you factor it and you notice that both of them are the same, now it has to be the same in order to be a perfect square trinomial, otherwise it's not. Instead of saying A plus 1 times A plus 1, or actually it would be the sum of A and 1 times the sum of A and 1, instead of saying it that way, we could just say A plus 1 squared. All right, so let's go ahead and try another set. So I'm going to do the double parentheses again. Now, 81, so we're trying to multiply two numbers to get 81. And again, this is just FOIL, but backwards. If you remember FOIL, you know, you have to multiply first numbers and then outside numbers and then inside numbers and then last numbers and add them together and you get something like this. This is the exact same thing, but backwards. And again, I'm trying to keep this simple. 81, I can get that by multiplying 9 times 9. And we could try other numbers, you know, you could try like, you know, 3 times 27 or something like that. I don't know if that's going to work out. But in this case here, we need two numbers that multiply to 81, but when I add them, will give me 18. But actually, specifically, negative 18. So you might be thinking, well, what if we were to put plus in there? Now, when we add them, 9 plus 9 will give us positive 18, not negative 18. So again, this sign means that they are going to be the same if it's positive. It does not mean they are both positive. In this case, actually, they are both negative, because negative 9 times negative 9 is positive 81, and negative 9 combined with negative 9 makes negative 18. So that's how we know this works. And I'm going to go ahead and put M in here. And we end up with two parentheses of the same thing, two bubbles of the same thing. They are both M minus 9, or the difference of M and 9. And since they're the same, I can make it easier by just putting square instead of writing it twice. And I could do the same with this first one too, because now that we know that that's something that we can do, I can get rid of this parenthesis and put a square here. And let's go ahead and do the last one now. So I need two numbers that multiply to 25, but when I add them, I get 10. So Okay, well, 5 times 5 is 25, and 5 plus 5 is 10. So we know that these numbers are 5. Oh, and I was talking about this method here. So that was the last number. To get the outside and inside numbers, which are actually the signs, to get the signs, we need to take into consideration this one. So that's the OI, sorry. I was every time I look at Loif method, I always think of like British people. Oi, how's your Loif? But anyway, in this case here, we know that it's going to be negative. Or sometimes with the OI, they'd be like, oi, bloke. Anyway, so P minus 5 squared. They're both P minus 5, so I'm going to go ahead and erase one of them, just so that way it's a little bit more closer to what we would actually be doing. And that's a quick rundown on factoring. I think in the future, the next lesson after this is going to be more on factoring. So if factoring doesn't make sense to you just yet, or if you've completely forgot it again, then don't worry, we're going to do more of it in the future. But what we need to know right now for today's lesson, but what we're doing again is we're turning standard form into vertex form, because if you remember from the other lesson, graphing in vertex form is actually kind of easy, and it's a little bit faster. So sometimes you might want to put something in vertex form. So in this case here, we're trying to look for something that's like a perfect square. So basically like the 4 exercises that we just did. So we've got to factor it and then convert it to vertex form. If not, you can use a process called completing the square to write the equation in vertex form. Now, looking at the standard form, you have ax squared plus bx plus c. Step 1 is to group these together. So that's all we do. We just put them together, put a group on them, and that's it. If they have any similar factors, we have to divide both of them. Now, this is like that one, like distributive property. Okay, we all know about distributive property, right? If you have parentheses, you multiply both numbers inside the parentheses, or however many numbers there are inside the parenthesis, by the outside number. But in factoring with a parenthesis, you take it out. So you're taking something from both of those numbers. Basically, you're dividing both numbers so that they have the same number on the outside. Now, to complete the square, you take b, all right? So I call it, well, let me read it first. By taking half of b and squaring it, this will become your new c value. Add this to your existing group. So that group that we put aside, we're going to add it. That's going to be the perfect square trinomial. And at the same time, we're going to subtract that number that we added, because if you remember an equation, you can't just, if you're having an equation, you got to do something to both sides. You got to keep it balanced. If you just add or subtract, then you're not working an equation. So anytime you do something, you've got to do it to both sides. So it takes that same idea. And for number 3, I call it take it, half it, square it. So that's kind of the way, hopefully that kind of sticks in your mind. It's an old song, but there's like, if you say it enough times to yourself, you won't be able to hear the original lyrics anymore, but take it, half it, square it. And then factor the trinomial and simplify it. So again, this looks like a lot of steps, and I know you're probably still confused. Maybe it'll be a little bit better once you see this process in action. So we got to convert these standard form trinomials into vertex form. So write it in vertex form and give the vertex. So the first thing we want to do again is to group these two numbers. So it's grouped. Next, we check it to see if there are any numbers we can divide both numbers by. And in this case here, there is none. Okay, now we could take an X out from both of them, but that's not going to help. So we didn't take anything out. So let's take our b value. So remember A, B, C. So we take our b value, so take it, half it, square it. So we take 4, divide it by 2, which is 2, and then we square that so that we get 4. Now in this case it does seem a bit confusing because, well, wasn't it 4 to begin with? Now it is 4, but it's a different 4, even though we already have 2 of the exact same ones. Okay, so now we know it's 4, so let's go ahead and plug it back in. So we have our group here, x squared plus 4x plus 4 on the outside. Now this 4 here, I'm going to minus it here and minus it here, or add it here, I should say. Now, if you add 4 and subtract 4, you're going to end up right back where you started. So you didn't change anything. And that's what I mean by we got to keep it balanced, right? So if we do one thing, we got to make sure we undo it later. So if I add 4, then I have to subtract 4. And then from here, we're going to turn this into a perfect square trinomial like we did with the first 4 exercises where we had to factor them. So think of 2 numbers that multiply to 4, which is pretty easy, but make sure that those same numbers add up to 4, which in this case is 2, right? 2 times 2 is 4, but 2 plus 2 is also 4. Check your sign. This sign means that they will be the same. The signs in each bubble will be the same, which if they are the same, they will be the same as whatever the first one is. So plus 2, and for the F in LOIF, F is for first, so we look at the first number and think, what 2 numbers can I multiply to get x squared, which in this case, there's no a value. So the only way to get x squared is to multiply x times x. And in this case here, I get, on the outside, 4 minus 4 is 0. Now, since these 2 bubbles are the same, I am going to and I'm going to put it in Vertex, function notation. Well, actually, that's not our answer. So our actual, well, I guess, okay, it says write it in Vertex form, so I guess it is kind of our answer. So that's part 1. And the second part is basically what we did yesterday. Look at the vertex, but remember that this number is going to be opposite. So it's going to be -2, 0. And I don't really need the 0 in this case. I just left it there so that way you know where this 0 came from. So with this 0, you can take it or leave it, okay? But I just want to remind you that if you don't have anything there, or if it canceled out, it would be 0. Okay, let's go ahead and try the next one. This one hopefully, well, okay, so again, that first one was a little bit tough to follow because there are so many 4s, and since they're all 4, it's like, which number is which? Where is, you know, what's going where? So let's go ahead and do this one now. So first things first, we group it, and we check to see if there's anything we can divide both numbers by, which in this case, there is none, right? I don't have any numbers I could divide both x squared and -8x by. So let's go ahead and take our b value. So in this case, it's -8. So take it, half it, square it. So take it, half it, square it. So -8 divided by 2 is -4. And then we square that so that we get, well, -4 times -4. And don't forget, if you multiply 2 negatives, you get a positive. So in this case, we get positive 16. Now, maybe if I color code it a little bit better, it'll make a little bit more sense. But in this case here, we get our function, and I'm going to rewrite it again. Now, I'm going to leave a space right here and continue to add 18 here. So x squared minus 8x plus 18, so it's all there. But we got 16 here, so I'm going to add 16 here and minus 16 here. That way it keeps it balanced. If I add 16, I have to make sure to take it away later, right? Because we can't just be putting numbers in there and taking numbers out, right? That breaks the law of equality, a law, you know, with equations, you always got to do something to both sides. So in this case, it helps us get around that rule. Okay, so let's go ahead and factor this the same way we did. So I'm going to go ahead and take double bubble. And if these are perfect square trinomials, it's going to be a little bit easier because both numbers are going to be the same. And it pretty much has to be the same, because if it wasn't, then, well, we made it so it has to work. We made it so that it has to work. All right, so I need two numbers that multiply to 16, but will add to negative 8. And you might be thinking, well, 4, and you're right, 4 times 4 is 16. But again, be careful, because this plus on the 16 doesn't mean that they are both positive. It means they are both the same. All right, so if they are the same, they will be the same as whatever the first one is. Now, if we use FOIL, first numbers, x times x is x squared. X times negative 4 is negative 4x. Inside, negative 4 times x is also negative 4x. Negative 4x plus negative 4x is negative 8x. So that's how we got that middle number. Negative 4 times negative 4 for the last one is positive 16. So that's another way you can check your work to make sure you're doing it the right way, is to multiply it out. Now, let's take care of this outside number here. So 18 minus 16 is going to be 2. So we got 2 on the outside. And now I'm going to simplify it. So instead of saying both of these all out, well, let's go ahead and just rewrite it as one group squared, because again, whenever you see a square, that means you have 2 of those things. So now we have our vertex form. But we also have to give the vertex as well. So vertex is opposite of negative 4, so that's positive 4, 2. And I really should put this in a box too, maybe next time. Okay. All right, yeah, I know this is a lot of stuff to bring together. All right, so let's go ahead and work on this. Now, with this one here, we have a negative in the front. Now that negative is going to make a difference, because if you remember standard form, in general, you can't have your first term be negative. And that's not to say that it always has to be like this. Now, if this was a parabola, it would be opening down. But what I mean is, in this case, if we're working with it, that negative is going to throw some stuff off. So we're going to have to get rid of that negative. So if we group it, let's take out that negative. So negative is out, which is going to change this sign, and it's going to change this sign. So just like distributive property, so if you remember those first few lessons, I kept reminding you that anytime you have a negative in the front of a group, you switch the sign of both pieces in that group, both elements, both terms. So there we go. So we switched it out. Now what we got to do is take our new b value. So this is our b value here. And the b values include the sign with it. So in this case here, we take -6. So again, take it, half it, square it. Take it, half it, and you get -3, and we square that. Now when you square a number that has a negative, well, when we square the whole thing, including the negative. So that would mean -3 times -3, which is 9. Now let's go ahead and take this, our original equation. Well, actually it would be -5 here. So this would be x squared minus 6x. And I'm going to leave a space here for this number here, because again, we have to make it perfect square trinomial. So if you remember from this slide, that's what you're doing. You're taking your b value, you half it, and then square it, and that gives you the new number that you need. Oops. So now I have my original equation. So negative x squared minus 6x, but then I have the -5. It's a little bit modified, but it's still the same thing as the original. Now I gotta add 9 in there. And when I add 9, I'm also going to have to -9. Or actually, hold on a minute. There's a little piece I almost missed, and that is the AC. So when we switch back to this slide, the AC here. So with the AC, if you think about it, if we were to multiply everything by negative, that would flip the sign. And flipping the sign would make it positive. So actually adding 9 here is not adding 9, we're minusing 9. So to counteract, to balance it out, we need to add 9 instead of subtract 9. Yeah, I know. I know. All right, so let's go ahead and turn this into a perfect square trinomial. So I need two numbers that multiply to 9, but will add to -6. And they're both, and in most cases, in all cases, if it's a perfect square trinomial, it's going to be the same number. So 3 times 3. But 3 times 3 does make +9, but they will not add to -6. So again, this tells you that they are going to be the same. And if they are the same, they will be the same as whatever the first one is. So in this case, they are both -3. Because -3, put them together, you get -6. First number is x squared, so that's going to make it pretty easy to get our x squared. And I'm going to go ahead and combine my outside number, so 9 minus 5. And it's just easier for me to do it that way, 9 minus 5, because you can reverse the order of these as long as you keep the sign with the number. So again, 9 minus 5, and that's going to be 4. Now we just have to put it into vertex form by combining these two things. So negative difference of x and 3 squared plus 4. So put these together and I got a square, but I'm going to go ahead and put f of x here to put it into function notation. And in this case, we have enough for our vertex. So the vertex is opposite of this one, which is 3, and the actual number of the last one. So Vertex is 3, 4. All right, that one was a tough one. This next one's going to also be a tough one too. So let's go ahead and follow the steps that we were given. So we're going to group this first part together. So if I have 2x squared minus 12, and I group it, now, oh, I almost forgot the x in this case here. I need to take away a factor of both of them. Now, when you say take away a factor, that's a little bit misleading because some people will say, didn't you just divide both numbers? And that's kind of true, but when you divide a number, you're taking one number and splitting it into however many parts from the other number. In this case, you kind of are dividing, but we call it factoring because you're removing a factor, and factors are numbers you use to multiply. So this number is 2 times 1, and this number is 2 times 6. So what we're going to do is remove a factor of 2 because they both used 2 in their multiplication. So take out a 2, or again, it's kind of like dividing, but it's not technically dividing. So I took away a factor of 2 to both of them. Now, if I were to multiply this back out using distributive property, I would end up right back here. But again, that's what we got to do. We got to take out that one number. So there we go. Here we have our b value ready to go. And in this case here, our b value is -6. Now, lucky for us, this is the same as this here. So I could literally take this and do it again. Oopsie. Like that. All right, but that'd be kind of messy. So anyway, in this case, we take 6 or -6, half it, and square it. And we get 9 again. Now let's go ahead and get our formula here. So -2, and we need to use this part here. And I'm going to leave some space because we need to put this 9 right here. And 13 is our outside number, so plus 13. Now let's go ahead and add 9. Now, when we do this, we have to kind of be careful with what we did here, and that is we got to take into consideration that this is not 9, okay? It looks like 9, it smells like 9, but it isn't 9. It could even taste like 9. But don't let your eyes fool you, because if I multiply out this 2, it will actually be 18. So if you remember from here, we get A times C. And if you remember the vertex form, you have A here, right, on the front of the vertex form. But basically, as simple as I can make it, 2 times 9 is 18, so we're going to have to put 18 right here. So in a way, I'm adding 18 here, and, oh, well, not adding, I need a minus 18 actually. So minus 18 from both sides, or add 18, minus 18. Whew. Okay. Now let's go ahead and factor this out. So this 2 stays there. We didn't do anything to get rid of that 2, so it's going to stay there. And I need 2 numbers that multiply to positive 9, but will combine to make -6. Now in this case here, that's pretty easy. And again, they're going to be the same number. Now this positive means they are going to be the same sign. So that means they could either both be negative or both be positive. But in this case, they are going to both be negative because, well, -3 and -3, if I put them together, I do get -6. But like, okay, so if I put positive, just saying, okay, what if, then I would get positive 6x, not negative 6x. So it's got to match there. So don't forget, you can double check your work by using the FOIL method. And there we go. Now we have to turn it into vertex form. So f of x. Now we have to include that 2 there because it's part of it. Now that 2, if you remember from yesterday or the lesson before this, when you increase that a value, you are going to get a vertical stretch. So you are going to have a narrower parabola. And we simplified our x minus 3 number so that we get, well, only one x minus 3, but it's squared. So it tells us we still have 2 of them. But now it's in vertex form. Now that it's in vertex form, we can easily see our vertex. So it's asking for the vertex, so we got to make sure we give that vertex. Now, again, it's going to be the opposite here. So it's going to be 3 and -5. And that's it for that one. Box this answer. I'll just put a large bracket on it. Because I notice that sometimes when I draw big boxes, I get, well, I don't know, maybe that's also confusing too. Because I notice sometimes when I draw big boxes, I'll pass through a number or something like that. But I always like to have numbers boxed. Anyway, let's go ahead and go to the next one here. So write each function in vertex form and give the vertex. So I have more stuff going on here. All right, so number 5. We group this first group here. Sometimes you can do this just by looking at it. And in this case, there's nothing really that I can take out, right? If we remember the last one, we could divide both numbers by 2, but in this case, we have nothing that we can divide both of them by. So we can't do anything with this, so we're going to go ahead and just leave it as is. So let's go ahead and take our b value. So take it, half it, and square it. Oh no. In this case, we end up with a fraction. And I'm trying to think how we can do this. Now, I mean, it'd be pretty easy to go like -1.5 and square that. But I'm a little bit, like, I'm not really sure what's going to happen in the future. So let's, oh gosh, do I turn it into a decimal or do I leave it as a fraction? I wish I had a coin to flip. Let's leave it as a fraction and just see what happens. Now, the reason I want to leave it as a fraction because I know in future courses and future lessons, this is going to come up again. Because squaring a fraction is a little bit different. So when you square a fraction, you're multiplying one fraction times another fraction of that same one. And if you remember multiplying fractions, top number times top number. So in this case, -3 times -3 is +9. And multiply your two bottom numbers together. So we don't need to do any tricks with this one. So that's why I think I'm just going to leave it as a fraction. And I get 9/4 as my b value, as my new b value, I should say. Now I'm going to go ahead and rewrite my original equation, x squared minus 3x. Now, there's no funny business here. I didn't factor anything out. So I can go ahead and keep it on the simple side and leave a space here while I write -2. Yeah. Now I'm going to go ahead and put 9/4. So add 9/4, but minus 9/4 here. Now, if at any time I ever want to convert these back into decimal, that's going to be pretty easy. But if I have decimal, it's going to be very hard to transform it back into fraction. You can do it and you can get pretty good at it, but it's not something I really would expect a lot of people to be good at. So that's, we can always turn a fraction into a decimal, but it's way harder to turn a decimal back into a fraction. Now, let's see if we can factor this out. So now, if this was I'm kind of glad I left it as a fraction, because this is going to be a lot harder to factor it if it was like, well, 9 over 4 would be 2.25. And it's a lot harder to ask yourself, what two numbers can I multiply to get 2.25? But here, if you look at the pattern of what's going on, so when you take your 6, you take it, half it, square it, you basically do that same thing the other way. So let me see if I can find a really good example of it. Probably this one here. So you kind of get the root. You get the root of this one, but you get half of the b value. So again, if you take 8, divide it by 2, you get 4. Take the square root of 16, you also get 4. Here we take half of -6, which is -3, and you take the root of 9, which again can include both negative and positive 3. So in this case here, we take the root of this number, which is now an even better shortcut is you just take this number right here. And I don't know how I forgot that. That's like the thing that'll make everything super easy. Because if you look at this number right there, here in the middle step, -3/2, right before you square it, all the b values were that number, -3, -3, right? Because that's the factor that goes here and here. And here we had 2, right? So we have 2 right there, 2 right here. -4, -4. Okay, that actually makes it a lot easier. And here, I'm going to go ahead and convert 9 over 4. Now, in this case, again, it's good to have both of them because I can turn 9 over 4 into a decimal. And I think I said a number earlier, but I'm going to double check it. So it is indeed 2.25. So in this case here, it would be best to leave them in the same format. So that would be, well, it's a minus on both of them. So it's going to be -4.25 because again, this is 2.25. So -2.25. And since they're both negative, that's going to make a bigger negative. All right, so f of x equals, and I'm going to put these two together. So x minus 3/2 squared minus 4.25. And if I wanted to, I could turn this back into a fraction. Some numbers are easy to turn back into fractions if you had to. Like in this case, it would be 4 1/4. But that one would probably be more of memorizing and being familiar with fractions rather than actually knowing how to work with them. Okay, so now it is in vertex form, so we give the vertex v, and if I want to, now in this case, if I'm graphing it, it might be easier to put it into decimal when you're graphing it. So sometimes it depends on context. Like if you're working with a slope, slopes are best left as fractions. But y-intercepts or axis of symmetries, or in this case vertexes, might be better to leave as decimals. Because if I told you to mark on a graph, over 1.5, and down 4.25, that might be easier than saying, I want you to go on the graph 3/2 and 4 1/4. See, that's a little bit tougher. That's a bit tougher to think about where that goes on the graph when you say fractions, but decimals, a lot easier. All right. Boy, this is a fairly long assignment. I'll pick up the pace maybe a little bit. Hopefully we're getting a little bit better at this. So let's group this. We are gonna have to graph it eventually. So in this case here, they are both negative. And when you are trying to get a perfect square trinomial, it's a lot harder when it's a negative. So that means I'm gonna have to factor out the negative first. And that's gonna reverse the sign of both terms inside the parenthesis, inside the group. Now let's go ahead and take our 9. So take it, half it, and square it. So 81 over 4. So all I do is square the top number, square the bottom number. That's kind of an easier way. But again, actually what you're doing is you are doing something like this. You're multiplying 9/2 times 9/2, which would still get you the same number. But now we have our b value. Now this number here is also going to be our inside factor number. So that's going to save us a little bit of time. So hopefully we can rewrite this a lot easier. So negative x squared plus 9x, leave a space, minus 22. So I rewrote the original equation using this new parenthesis area. And now, again, just because now I know that it's best to leave it as a fraction until you decide what's better, let's go ahead and put this fraction back in so we get, I'm going to have to make this one positive, which this part's always going to usually be positive, almost always. Now, in this case here, I'm actually minusing 81/4 because this minus means everything in here is actually a minus. So that's why I'm going to double this one again, 81/4. Now 81 over 4, and I'm going to use my calculator. 81 divided by 4 is 20.25. I'm going to make that 0 a little bit better. 20.25. So that's going to make it a little bit easier to work with. Now I'm going to go ahead and use this number, because again, it's the root of this number, but half of this number, or which is actually 9 over 2. 9 over 2 is half of 9. So let's go ahead and put it together. So double bubble, and it's going to be plus, because this one's a plus as well. So again, they're the same, and they're both positive. So 9 over 2, 9 over 2. And I'm going to go ahead and put these two together. So that's 20.25 minus 22. And that's going to be 1.75. So minus 1.75. Now again, I could, at this point, I could easily turn these back into decimal. Just 9 divided by 2 is 4.5. In fact, you know what? I think I'm going to do it that way for this one here. So again, leaving them as fractions at the last minute might actually be a good thing. So, you know, I think I'm going to do this from now on. Anytime I run into a problem like this with fractions, I think I'm going to leave it in fraction for as long as I can, and only turn them into mixed numbers at the last minute or decimals at the last minute, depending on which one I think I need better, you know, which one is more appropriate to show your answers in. Last order of business is to get our vertex, which is going to be opposite. So 4.5, and again, this is a lot easier to show a decimal on a graph rather than a fraction. So that's why I'm going to put my vertex in decimal form. But if I really wanted to, I could leave my vertex formula in fraction form. And there we go for that one. Okay, so again, it's getting a little bit faster now. Hopefully we're learning some of these tricks that we got. Now, for number 7, it looks like we have no C value. So if there's no C value, that might actually make things a little bit easier. If we group it, okay, there's nothing in front of this X, so it's not gonna make a difference. So we can immediately start with the taking it, halving it, squaring it. So take it, half it, square it. So 25 over 4. And again, we could easily turn that into a decimal. So 24 divided by 4 is 6. So this would be like 6.25 or something like that. But we don't really need the decimal now because it might be easier to just leave it as a fraction. So again, B value, take it, half it, square it. Now let's go ahead and plug it back in, which we didn't make any groups, so we don't have to worry about regrouping it or anything. Leave some space in here. And here we have plus 0 because there's nothing over here. And I'm going to go ahead and drop in 25 over 4. And if I do whatever I do to this side, I have to do the opposite to the outside. So minus 25 over 4. And we know 0, anything added or subtracted to 0 is going to be that same number, so it's not going to make much of a difference. Now again, your middle step, or the root of this and half of that, are going to be in your bubbles. So in this case here, they are both, this means they are the same and they're both positive, so x plus 5 over 2 squared minus 25 over 4. And you know what? I'm going to go ahead and skip that middle step where I put the two things together. Because in this case, we're done now. So now that you're getting a better feel of it, I feel like we can go ahead and take some of these out, some of the steps. And again, all I did was not put them all together, which actually works out with this one. I think this one particularly works out because we don't have a C value. Anyway, last order of business is to give the vertex. And I'm going to do this in decimal as well. And you can just leave it like this. You can leave it as 5 over 2 and negative 25 fourths. But I'm going to do it just because, again, if I had to point out this part on the graph, I think people would have a much better result if they were told in decimal. But decimal fraction works out okay. And that was it for that one. That one was actually a fairly quick one. All right, so if we group these ones here, we do notice that there is a number in front of the x square. So what that means is that we are going to have a group like this, and we are going to have some numbers on the outside. So we're going to have to think of what number we can divide 4 and 8 by, which in this case it's 4. So x square minus, and then divide that by 8, or 8 divided by 4 is 2. So now we have our b value, which is negative 2. So negative 2, we take it, half it, square it. So negative 2, divide that in half, it's negative 1. Negative 1 times negative 1 is positive 1. So that was kind of easy also. Okay, now let's go ahead and put this back. Now I'm not going to put the, well, there's nothing else to put, so I'm going to go ahead and just put it here. and I'm going to have to add 1 here. But remember, it's not actually 1. It looks like 1, all right? And it could fool you thinking it's 1, but it's actually a 4, because if I multiply 4 times this number, it would be adding 4, not 1. So that's why I have to minus 4 to keep everything balanced. So again, to keep everything balanced, if you put something on or take something out, you got to take it back off or put it back on. So you do the opposite of whatever you just did. So in this case, again, I added 4, so I have to minus 4. Now, we can go ahead and put it into our vertex form. And like I said, normally I do the double bubble like this, but by now you're probably also noticing that sometimes you don't really need to do that. So we need 2 numbers that multiply to 1, but will combine to -2. So 1 times 1 is +1, but -1 added to -1 will make -2. Oh, what was I thinking? I was going to put it in the vertex form, but I started writing the formula, but I still need f of x like that. So f of x, x minus 1 squared minus 4, and that's it. We just need our vertex form, and vertex is 1, -4. Okay, now this lesson does seem like it's a bit longer than usual, because we never really had the bell, but keep in mind we started late. All right, it was like 15 minutes before the first person showed up. So, you know, if you want to get out of here on time, you better get here on time. Anyway, let's go ahead and again, let's see if we can make this quick. Group this, and I can take out -2. So if I divide this one by -2, I'm only left with x squared. That's going to reverse the sign and divide that by 2. We get x, like that. Now we can get our 10, our b value. So we take it, half it, square it. So half of -10 is -5. -5 times -5 is +25. So we end up with, well, 25. -2x squared minus 10x. Leave a space. And it looks like we also have -46 here. And now I have to add 25. And when you have it in this parenthesis, just kind of a hint, it's always going to be a positive number, because you can't really take a perfect trinomial if it's negative, because if it's negative, that means it can't be a perfect trinomial. I'll keep it simple. But now I have to add 50, right? Because multiply these two together, -2 and 25, multiply them together, you get -50. So I got to do the opposite of -50 and add 50 to both sides. So that's going to be +50. And then from here, we can go ahead and just put it in our vertex form. So -2. And again, it's going to be this number right here. That's going to be the number in here, x minus 5. And what's 50 minus 46? I'm just, okay, 4. Okay, there we go. And vertex form, opposite of this number, and actual value of this number, so 5 and 4. And that's it for that one. Again, these are not as bad as you think, but I understand that they can be confusing. And in a normal school year, normally I break it down so that way, you kind of work one step at a time. So it's a little bit easier. Now in this case here, this one's a really tough one because we have a fraction. And getting trinomials to factor nicely with fractions is really tough. So we're going to have to divide by this fraction. And this is another tough one because if I ask people, what is, okay, so if I take 4 and divide it by half, what do I get? And this is one of those like puzzle questions that I usually give. And without missing a beat, most students will say, oh, it's 2. But I said divided by half, not divided in half. I'll show you what I mean. If I put 2 here, let's check it. -1/2 times 2. Well, that's going to give you 1, not 4. So what number do I have to times by 1/2 to get 4? And this is a trick question because it's 8. Now check it. Multiply both of them by 1/2 and you will get the original equation back. So that's, again, that's one that's a really tricky one. So now let's go ahead and take our 8, which is our b value. So take it, half it, square it. So I got 16. So let's go ahead and put 16 into our formula. Now, when you have a fraction in vertex form, remember that's going to be a vertical compression. So this graph is going to be a little bit wider than a normal graph. And I'm going to leave some space here, and it's got a -5 on the outside. So I rewrote the original, all right, with this part combined on it as well. So we still have the -5 on the outside. So add 16, and again, we still have the same problem. It looks like 16. It smells like 16. It acts like 16. Well, actually, it doesn't act like 16 at all. And that's how we know it's not exactly the same thing, because it's actually 8. And this is actually -8, so that means I have to add 8 right here. Okay. -1/2 and then x. And it's going to be this number again. So it's the square root of this number and half of this number. So half of +8 is 4. And if it's positive, so it's more of this one actually. It's half of this number. Because if this number is negative, like if it's 5, right? If it's -10, it's going to be half of that. So it's more of this one here. Anyway, 5 minus 8 is 3. So I'm going to add 3 in like that. And I think we are done with putting this in vertex form. Since it's in vertex form, we can easily get the vertex. So opposite of this, same as that. So -4, 3 is going to be our vertex for this one. And almost there, okay? Almost there. We just got 2 more to go. So let's go ahead and move on to the next one. Convert to vertex form, identify the vertex, get the axis of symmetry, and then graph it. Okay, so if I group it, I can't take anything out. So there's kind of a shortcut with this, and that is if there's nothing here, then you can't group it. You can't take anything out of the group. So let's go ahead and take -12. So take it, half it, square it. Now let's rewrite our equation, x squared minus 12x, leave a space, plus 39. Now I'm going to add 36. Now this one has no funny business going on. There's nothing out here, so I can go ahead and just add 36 and minus 36. And in this point here, we're going to go ahead and take half of this, or this middle number here in our value, which is why I do the take it, half it, square it. And you notice that I write it like this. And the first few exercises, I didn't do that. I wrote out every single thing, because when you do the take it, half it, square it, it's that middle step that will be this number here. And now I'm going to go ahead and combine these two outside numbers. So 39 minus 36 is going to be plus 3, and put our f of x on it. And there we go. It is in vertex form, but we still got to graph it. So vertex is opposite of -6, and our axis of symmetry. So axis of symmetry is going to be x equals 6. So that means it's going to be symmetrical to this point here. Our graph is going to be over 6 up 3 is where the vertex will be. And in this case here, that's going to be our inside number here. And yesterday I showed you guys what did I show? I showed the faster method of graphing, and that is the rule of odds. So if you have no a value, you can use the rule of odds, and the rule of odds goes difference of 1, difference of 3, 1, and then up 1, and then up 3, and the next one would be up 5. And I can just mark these parts on the graph. So if I go over 7 up 4, that's the dot, and over 5 up 4, that's also going to give me a dot. Over 4 up 7. And from here again, I'm just going to add 5, so 7 plus 5 is 12. Now you can do what we have done before. Take your original equation and substitute each of the values in for that number. So take those numbers that you get and plug them in. So erase this, erase that, and then start plugging in 9 into these and evaluate it, or whatever number you want to start off with. So if you want to start with the smallest one, you could start with 3 and then evaluate it, and you get 12. But again, that rule of odds makes things go by a lot faster. Last thing we need to do is graph this as best we can. See, there we go. So even that was pretty quick. But again, I'm trying to go a little bit quicker through this than I normally would. Maybe. All right, we finally reached it. The final question. This one does have, if I were to group these first two, I do have something that I can take out. And in this case, they can, well, we got to get rid of this negative in the front term. So that first term cannot be negative if we are trying to get a perfect square trinomial. So this means we're going to have to take out -3 from both of them. And that's also going to have the effect of reversing the sign of the second term. And I get 4x. Now again, we take our b value, take it, half it, square it, which in this case gets me right back to 4. Let's write our formula here. So -3x, oopsie, we have to write it like this on the first part. So leave a space in there and -8. So there we go. Now we take our new value here, add 4. But again, we got to multiply this part here. -3 times +4 is -12. So this means that we are going to have to, since we're minusing 12 on this side, we're going to have to add 12 here. So again, -3 times 4 is -12. since we're minusing 12, we got to offset that, balance it back out by adding 12. Now, let's go ahead and put it into function notation. So that's going to be f of x equals negative 3. And this one's going to be a pretty easy one. X, and we take half, we take this number here, so plus 2. And we can double check it again if we FOIL it. So x times x is x squared. X times 2 is 2x. Inside terms is going to be 2x as well. So 2x plus 2x is 4x, and 2 times 2 is 4. And there we go. Now we have our vertex form for this graph. So let's go ahead and get our vertex and axis of symmetry sorted out. So vertex is negative 2, 4. And axis of symmetry is x equals negative 2. I'm going to go ahead and graph that. So negative 2, so there's our axis of symmetry. And we also know that it's going to be the middle number here. So I can start filling in some of these numbers. 1 and 2. All right, so negative 2 up 4 is right there. So that's my vertex. The negative a value means that my parabola is going to be opening downwards. And in this case, it looks like we are going to have to fill in some of these numbers because we can't use the rule of odds because of this 3 here. I can't just go, 1, 3, 5, 7. I can't do that. So we're going to have to actually go back to the original equation and start filling in some of these numbers. So negative 3 x squared is going to be our first number. So I'm going to leave it with a parenthesis, square minus 12x, but leave x open, minus 8. Okay, so let's plug in 0. Now, I know that it's going to be symmetrical, so I'm going to take a shortcut and only do these bottom 3 here, because I know we're a little bit over time anyway. So let's plug in 0. Now that one's going to be a really easy one because 0 squared and 0 times anything is going to be 0, so it's going to be 0 minus 8. Oh wait, I completely forgot something. I don't know why I messed this up. I mean, we are going to use 0, but not just yet. So in this case here, I got 0, so that would be negative 8. Oops, almost made a mistake there. Which is a good lesson because you should never, trust yourself so blindly that you don't believe you'd ever make a mistake. We all make mistakes. The only difference between, say, you and NASA engineers is that NASA engineers check their work and look for mistakes, hoping to find them, so their satellite or rover doesn't blow up. All right, so let's go ahead and do this. So this is going to be positive 1 because we square it. So that's going to be negative 3 plus, because negative times negative. And in this case, we're going to have negative 13 plus 12, or 12 minus 13, which is going to be negative 1. So I'm going to put negative 1 in here. And then at this point here, well, let's just do the last one. So that one would be, well, actually, I think we just need 1. We would just need 1, so 1 in here. 1. All right, so 1 squared is 1 minus 3. And in this case here, since it's not negative times negative, it's going to be negative 12 minus 8. So I got a big number of negatives, which in this case, if I put them all together, is negative 23. Now I'm just going to mirror both sides, and in this case, even if I got some of these wrong, it probably wouldn't affect the graph all that much, especially this last one here. Negative 23 is way off the graph. All right, so let's go ahead and graph these points here. So we got negative 2, 4. Okay, that's our, okay, negative 1, 0, -8. And just mark the reflections of each point. So this is a very narrow graph. I don't think this tool is even really going to do it. It's not. I can't get that narrow. Okay, messed up. Oh, wait. Now this doesn't look right, actually. That should have still worked. It should still work. I'm going to double check one of these numbers. Let's check, I'm going to check -3 just to see if it, because I think maybe I made a miscalculation somewhere. So -3. Okay. So -3 squared is 9. So that'd be -27, and this would be plus 12 times this would be 36, and that would actually make this +1. Put those together, you get +1. Okay, so I guess I did make a mistake, but like I said, that's not too entirely bad because everybody can make mistakes. Now, it should fit a bit closer to this graphing, to this parabola tool, and that does look a lot better. Okay, so, but I did notice that the shape was a little bit off. So if you are making parabolas and you notice the shape is a little bit off, again, it should be a constant curve from one to the other, and that curve gets faster and faster as you go down. So if you ever notice that it's not really quite working the way it should, don't be afraid to back up and be like, yeah, you know what, I really should check it. Okay. But that's it for today. As always, I'll be around if you have any more questions. If not, then I will see you guys Monday. Bye-bye.